Well, hello, Cal State Straub. We're going into day 2 of 10-1's notes. Hopefully you had a chance to work on your homework and from the first lesson and get to play with some of the basics of the confidence intervals. Hopefully today's notes will help it even be understood further. In your pacing guide, I have a link to this applet for confidence interval proportions, and I would like for you to listen to my instructions first and then pause your video and go and play with this. So let me pull that up. I pulled this app up in day 1's notes and showed you a little bit about it. But I'd like for you to go in here and change up the size of your sample. For example, if I go really small here, 20, that's a smaller sample size, and I take 25 of them, look at what happens when I have a small sample size. My interval, in order to be, 99% confident, I have to have pretty large intervals. If I go down and I'm to 95% confident, you'll see that my intervals can get smaller, but I'm less confident that the true parameter will be in there, and even yet down to 90. I think this app lets you go to 80, but 80 is not a common thing. But you can see that one thing I just want you to notice is how the interval sizes change. Okay. Also, I want you to change your parameter, move it left, right, see if that has anything to do with the size. You'll notice, look at some of these are pretty tiny. They're not all the same size. Here I had 2 that did not capture the true proportion. So I'd like for you to change sample size and then go really large with it. Oh, what happened when I went really large? My confidence intervals got pretty small. So think about that. What happens as n gets bigger? Now I'm gonna go a little smaller, and then let me go all the way out to the edge with 1,000, and look what happens with my confidence intervals. So I want you to think what happens as n changes, what happens as c changes, and does anything happen if my parameter is moved around? So just stop and take some samples and then come back for the rest of today's notes. All right. Hopefully I've blocked the video fine and you had some time to do that. Hopefully you've answered in Edpuzzle with some of your findings, and I'll take a look at those. Okay. So let's continue on seeing if we can make these confidence intervals. Again, 10-1 is just about doing the basics. We're going to really hone in on means and proportions with the next 2 sections. You should be a CI Pro by the end of this chapter. All right. So conditions to run your confidence interval for mean. I'm just going to start just as an example using the true mean. Okay. You must make sure that you have taken an SRS, that you have a simple random sample of items. You need to check for normality. That means for mean, is n greater than 30 or greater than or equal to, then it's okay to assume normal by CLT, and you'll need to cite that. Since n is 50, which is greater than or equal to 30, by CLT, I can assume normal. Okay. Usually SRS is given, so you'd say SRS given. You're going to check all your conditions. Check SRS, check, and I can use normal. Independence is the same thing as our large N factor we've been doing. But now we're just saying, hey, is this going to be independent enough? In other words, is N large enough that I can assume my samples are independent of each other and not just kind of like if N is small, then I lose some independence there. So what you're going to do is if your 10N is not the right size, okay, then you can lose that. Sorry about that accuracy. So is your population greater than 10N? So what we've already been checking these things, haven't we? Okay. So in order for you to use confidence interval, this is your plan part. If you recall, we use state, plan, do, conclude, and I'm going to walk you through how to use these with CIs. Okay. Your your plan here is that you have checked all your conditions, okay? So this only works right now when you know sigma, when the population standard deviation is known. Obviously, that's not very usual. Usually, we don't have the standard deviation of the population. We talked in class, there are a few times when there are large data sets where we keep track of everything. We talked about if it has to do with sports. You know, you want to know something about a football player, you can go back, and pretty much sports fanatics have been anal about keeping track of everything for years on sports. But most other data sets, we don't have the data on every single person that there is. So next section, we're actually going to address what to do when sigma is not known, and that will be using a t-statistic, okay? But in order for us to learn the basics right now in chapter 10, sigma is just going to be given to us just so we can learn it, even though that's not the normal way. We don't usually use z-statistic for this. T-statistic is going to be what we learn. And I'll explain all that in chapter 11. Okay. So Z star, you know, we got to have our French characters now. So Z star is our critical value. This is the number of standard deviations on either side of the mean that we're looking at. Okay. How many standard deviations away from the mean are we? Z star, it says here, marks off a specified area under the normal curve. And I tried to have a little diagram here for you with it highlighted. These two Z scores that mark off that area are called critical values of the distribution. So if you look at my chart, you'll see I have 80% in the middle. So this is an 80% CI, okay? Confidence interval means here's my mean in the middle, and 80% of the sampling distribution falls here. That means I have 10% in each tail, right? 80 plus 10 would be the 100%. So if each tail is 10%, I go to my Z table inside the table where the percentages are, probabilities, and I go and look what 0.1 is closest to. And if you follow 0.1 out to the Z score, you'll get negative 1.28. I should have mentioned, if you have not already, pause this and get your Z table in front of you. You're going to need that formula sheet for this lesson. Sorry about that. Take time to get that. All right, so now that you have your Z table in front of you, go on to the other side. Okay, that's actually at 0.9. If you see, if this is jiving with you, it's so hard when I can't see your faces and have you ask questions. But here's 0.1 to this point, and then 80% in the middle. So up to this point on the Z score, we're at 0.9. And so when we go to the table inside and look out, you'll get the positive 1.28. Well, of course, these are going to be opposites of each other because you have the same percentage in each tail, right? So you don't need to find both of them. You find one and you have it, okay? I have written over here for you the confidence levels for that are common, 90, 95, and 99, and shown you those Z stars that go with the common ones that are used. You're going to be using these a lot. So I'm going to also show you where to find them on your formula sheet so you don't have to have them completely memorized. By the way, your AP test is going to be open note, open book, open formula sheet. So yay. 1.645 there is for 90%. The most common one is 1.96 at 95%. But I just wanted you to see how these numbers come about. This was an example of how it happened for an 80% CI. Okay. All right, so now I'm going on to a 95% CI to see where those critical values lie. Okay, if you have 95% in the middle, that means you have 5% outside. So if you divide that by 2, you'll have 2.5% in each of the tails. So again, going to the table, I get 2.5%. Backs out to a Z of negative 1.96. That's where that comes from. Okay, so these are our critical values to say I am within 95%. So it's 2.5%, which is 1.96. That's almost that 2 standard deviations we were messing with yesterday when we were just doing a sample problem to keep it simple with 2 standard deviations. But to be more accurate, it's actually 1.96. So I just put a note here that this Z star, this is called that critical value, okay? This is with its probability lying to the right under the normal curve. This is called the upper P critical value. This 1.96 is the upper P critical value. Okay. The one down here is the lower P critical value, upper and lower P critical value. Okay. All right. So here's what our formula looks like now for our confidence intervals. Since we know that we can use X bar to be our point estimate for mean, we're going to put our point estimate here and then plus or minus our margin of our error. And our margin of error is how many standard deviations we are away from the mean for that particular confidence interval. So if it's 95%, Z star here is going to be 1.96. In the warm-up problem we did yesterday, we just said 2 standard deviations and we multiplied it by 2, if you recall. Now we're going to be exact and multiply it by 1.96 if it's 95%, or the other Z stars for if it's given as a different percent CI. All right, so what do I do, Mr. Strupp? Here's where you're going to, from the now to the rest of this, even with statistical inferences, AP expects you to do state, plan, do, conclude. Okay, so what do I do? Here's a great slide for you to remember. State your parameter. So what you're going to do is you're going to identify the population and the parameter that you're trying to draw a conclusion about. What is the population? What is the thing you're looking for? You're looking for the mean number of students online right now, okay, in the United States. So students in the United States is our population, and the mean number of students online is our parameter. Okay? Must state that at the beginning. What is it you're trying to look at? It gets your mind focused on what the math is going to be telling us. Plan. It's down now. Here's where you go through those conditions. Okay, you verify all those conditions. Is it SRS? Given. Is it normal? Well, if it's means, you use CLT. Remember, CLT is not for proportions. CLT is only for means. So if it's proportions, you have to do NP, and N times 1 minus P greater than 10. So you check to see if you can use normal. Check. And then you check the independence. Okay, are they independent? That's our 10N factor. You do that and say, is our population bigger than 10 times the sample? Okay, check. Cannot do these inference procedures unless those 3 things check. Okay, we're going to learn, and I'm going to tell you that even if you don't know for sure or it doesn't seem to check, what you're going to say is, this didn't work. For example, let's say I had an N of 20. That's not greater than 30. So I would have to say proceed with caution because CLT doesn't adhere here. Okay, so if anytime you have a condition that doesn't work, you go ahead and do the work, but you always say, but I had to proceed with caution, so I'm not sure this is accurate. Okay, and then do. So we've done state, plan, do. That's where you actually do the calculation. You just take your point estimate, which is your X bar or your P hat, if it was proportions, and you add plus or minus that margin of error, which is Z star times your standard deviation formula. Now, remember, the standard deviation formula for proportions was different. And so when we get into that chapter, we'll go over that one. Right now, I'm just focusing on means so we don't get all confused. Or maybe you are already. Hopefully not. Conclude then. Now, here's where you do that interpretation. We are 95% confident that, and that's where you interpret the results. You give me that conclusion. You give me that interval, and you make the connection back to the context of what's going on. Okay, don't worry, we're going to do a few of these to practice. So here, yesterday's notes, we did this. Sample of 50 students, SRS given, right, is taken, and the mean height of the students was 67 inches with a standard deviation of 3.9 inches. Construct a 95% CI for the true mean height of the population of students at MVHS. So I'm going to state what it is I'm doing, and I'm going to make sure my population and my parameter is in it. So what am I trying to do here? State what you're doing. We want to construct a 95% CI for the true mean height of students at MVHS. What is my parameter? The true mean height, right? What is my population? Students at MVHS. Make sure that's in your state. Now, plan. all of my conditions. SRS, given. That's all you have to state. Normal, well, 50 is greater than 30, so I can assume normal by CLT. You can't just say 50 greater than 30, check. You need to state why you can say that. So notice how I'm wording it here. Okay. And then independence. This is our 10N. 10 times 50 is 500. Always put your numbers. Don't just say 10N is less than N. You need to put your numbers in there. That's 500, which is less than the number of students, our population at MVHS. So all three conditions checked. Now I can go to the do. So we did state, plan, and now for the do. I just reworded the problem there so we could see it. Our point estimate is that 0.67. The X bar can be used as our mean. Our standard deviation of the population was 3.9. So remember, we're going to be dividing that by the square root of 50 over here, 3.9, right? Because C equals 95%, we know that, okay, here, I went ahead and did this calculation. You don't have to do this every time. I just want you to see where it comes from. If 95% is in the middle, right? That means 2.5% is in each tail. And that's where we got that 1.96 we looked at before. And then, so we're going to put here point estimate plus or minus 1.96 times your standard deviation of the population divided by N, square rooted. And we get this confidence interval. State, plan, do, conclude. And that's where you write your statement. We are 95% confident that. Please always start every conclusion for CIs like that, okay? We are 95% confident that the true mean height of MVHS students is between 65.92 and 68.08 inches. Done, okay? Now, I want to show you something about these Z-stars, okay? I'm going to show you where you can find them on your formulas table in case you forget these numbers. So excuse me for a moment. Oh, no wonder I didn't push play. I didn't get back to play on that. Okay, sorry about that, doing it so small. Let me move myself down. Here I have the AP Stats. Nope, wrong one. Where? Oh, I know where it is. Never mind, guys. You guys are being so good and patient with me. If I can come back down here. Here we go. This is what I wanted. The formula sheet. Okay, in that formula sheet right here, you have your confidence levels. Okay, do you see this down here? Confidence level C. All right, where did Mrs. Straub find this? Let me move me out of the way over here. I'm moving around the screen, isn't that great? And of course, I'm not finding my... Okay, in your formula sheet, when you go to the tables, you'll see table B that says T distribution. I know we're not in T distribution, we're in Z, but if you go down to the bottom of that, right there, it tells you your confidence level. So look at, there's that 90%, 1.645, because that's going to infinity. Okay, if you were going to infinity with your sample size, this gets you to your Z star of how much. So there's your 1.96 for 95. And if you go all the way over here to 99, which is the other popular one, there's the 2.576. However, you'll see for all these different percentage C levels, you just go to the T table. Hey, that's just a little trick to help you see where to find them when you don't know what they are, and you don't have to draw the little normal curves all the time, okay? While I'm here, we're going to keep going on the other, but I forgot to have you finish the back of that worksheet that you were doing when you were playing with this confidence level. So I just have here, what does the confidence level mean? I'm sorry, this is messy, but right here, if you can see this right here, it is the probability that the interval will contain the true parameter in repeated samples. Make sure that's part of your work, in repeated samples, okay? If I do lots and lots and lots of these, the probability that I will capture that true parameter is 95%, okay? And then down here, I'll give you a chance to, well, maybe you need more time to copy that one. Let me go back over that. What does it mean? Okay, remember, confidence interval, when we ask you to interpret it, when it says to interpret the confidence level, it's asking you to interpret it in context. When it asks you what does the confidence level mean, That's a different thing. It's just saying that this is the probability that we're going to capture the true parameter in repeated samples. Okay. But what can go wrong with a confidence interval? Okay. Well, a margin of error in a CI covers only the chance variation due to random sampling or random assignment. This does not have anything to do with undercoverage or non-response in a sample survey. If you've made mistakes in your sampling, that has nothing to do with what we're doing here. This, when we get to CIs and statistical inference, we're assuming that the data has been accurately collected. Okay. So that undercoverage and any other sampling errors that we talked about in chapter 5, that can lead to additional errors, okay, that will lower this chance, or make this chance variation bigger, but lower our accuracy. Okay. So poor experiment design can also lead to additional errors here. So we have to state here that we are assuming that the CI data given to us when we go to do a CI is given to us and properly collected. Okay. If not, we can have some errors there. Okay. Hopefully, if you didn't have time to get it all down, you can, of course, pause me and get it down. So let's go back to the notes where we were. Somehow I lost the screen. It didn't hit F5. Oops, of course, Mrs. Straub. Well, of course, we're going to review here, aren't we? Oh. And you conclude. No wonder I was going through this without having the screen up. Boy, you guys are so good to be patient with me while I learn all this. Okay, so that's where we just were. We went ahead and did the state plan, do, and conclude. Move myself out of the way a little bit here. See if I can get off to the side even more. Okay. So let's keep going here. We're almost, was that it? Oh, hey, that was the end of that. No, it wasn't. Should be able to go further. Because of this. All right, guys. There we go. All right. Here's another really big topic, and you'll have some homework questions on this to practice tonight, and that is margin of error calculation. Okay. Remember that your margin of error, you want that to be as small as you can. If you're trying to estimate the true parameter, you don't want a huge margin of error, because then you've got a wide range, which it could be. The smaller the margin of error, the more accurate you can get and closer you can get to the true. So how do you get that to be smaller? Well, if you make Z star smaller, okay, making Z star smaller will make that plus or minus part less. Okay, but if you notice, the Z stars are smaller, the lower your confidence. So if I go from 95% to 90% confident, I can get a smaller confidence, a smaller margin of error, but I have less confidence in my answers. Of course, if we made sigma smaller, thinking about the formula, sigma over square root of n, if that sigma is made smaller, then that margin of error, that Z star times sigma over root n, would also get smaller. But how do you change the standard deviation of a population? That's very hard to do. The other thing is if I make n larger, now that's in the denominator. So if I make it larger, that makes that margin of error smaller also. So I could take larger n's, and you saw in that little app, the larger n got, the smaller my intervals got, which helped to reduce my margin of error, right? Hopefully that's something you wrote about. Okay, but again, if you're going to make n larger, that does take more time and more money to sample more people and more items. Okay, but that is a way to help. So when we want to say, well, then what would be a good sample size for me to take? If my boss came to me and said, I need to figure out how many people to sample so that my margin of error is within 2 points. I can't have it go any bigger than that. So how many people should we sample? And this is a question asked all the time. Okay. So how do I know it? Well, here's your margin of error formula, that Z star times sigma over root n. You want it to be less than or equal to some margin of error they give, and then solve that formula for m. Okay, so here's an example. I know my sigma is 5, my standard deviation, and you want a 95% confidence with a margin error of 2. Notice what I did is I took the Z star for 95%, and then there's 5 over root n. This is our unknown that we need to solve for, and say it's less than or equal to 2. Okay. Well, what that does here, I just multiplied 1.96 times 5. Now, if you remember your math, to solve like this, I cross multiplied. So 2 times root n is greater than or equal to 9.8, because when this n comes over here, 2 times root n is greater than or equal to 9.8. Divide by 2. And then the opposite of square rooting is squaring. I shouldn't say opposite, the inverse. Inverse of square rooting is squaring. And you get n must be greater than or equal to 24.01. Now, for sample size, I would not say 24.01. I would have to go up to the next integer because it's got to be greater than this, okay? Since this is not an integer, my answer will be, boss, you need to sample at least 25 people in order to get that margin of error, okay? All right, so here is your turn. You want a 90% confidence within a margin of error of 1. How big should your sample size be? And let's just say sigma is 8. So I'm going to have you answer that and put your answer in Edpuzzle. Okay, let's see how you did. So you start off with your margin of error formula to be less than or equal to your 1 margin of error that you have. For a 90%, Z star is 1.645. You can go to that formula sheet and find it just above the T table and find it just above 90. Okay. I multiplied 8 times 1.645 here and then cross multiply and get square root of n must be greater than or equal to 13.16. Square both sides. So what is my answer going to be? The next integer above this, which is, we're going to say at least. Okay, we're not going to say 174 exactly, because the more we do, we know the lower our margin of error will be, right? So that 174 is needed when that will get us right at the 1. But if we want to go, we can go even smaller than that, the more we take. So we would say, hey, boss, you need to at least survey 174 people. Okay. All right, your turn again. Now this time I want you to see if you remember how to find Z star. So find Z star for an 85% confidence interval, and I put your answer on Edpuzzle. Let's see how you did. If 85% is in the middle, that means 15% is in the ends. Half of 15% is this 7.5% in the tail. So I went to my Z table to see what 0.075 percent will give me for a Z score. Okay. And I could also add that to 0.85 to get the upper Z. So you could have either found 0.075 and gotten the negative and taken the opposite of it, or you can add these two together and see it's 1.44. This would have been negative 1.44, but we use the upper P critical value for Z star. We don't use the negative, okay? Ooh, guess what? That finished that. So now I'm going to go to the warm-up. I know we usually do warm-up first, but this needed to be done after. Okay, so here is your first question for your warm-up. We have 2 of them. Let's see if I can get them both on the screen at the same time. And I want you to try and work these out and put your answer in Edpuzzle. I'm going to have to view it a little bit smaller. Wait, how about if we do one at a time? Let's do one at a time. Okay, that way you could see if you were doing the first one right. How's that? Okay, we have an SRS of 50 people from San Diego to see if we can find the true mean, should say number of times a family eats out in a week. So in the sample, the mean was 3.72. If sigma is 2.5, boy, that's lovely. Find a 95% confidence interval for the population mean. And be sure to check your 3 conditions. Follow the steps from our notes: state, plan, do, conclude. Oh, and you guys are going to love this. This is where we have to also sketch a curve and mark it accordingly. So with the confidence intervals, there, it's kind of nice and easy. You're just going to draw the normal curve, and you're going to have 95% in the center, and you're going to have your two values for the CI underneath each of those. So try number one, and then come back here and we'll go over the answers together. All right, hopefully you had some time to work on that. And sorry, this is a mess. This is very much a mess. But state plan do conclude. So state, we are constructing a 95% CI for the true mean number of times in a week that San Diegan families eat out. Okay, so notice we have our parameter, true mean number of times in a week. And then our population is San Diegan families. And we also noted what we are doing is constructing a 95% CI. So make sure you have your state clearly stated. Plan, did you check your three conditions? SRS, yep, it's given. Normal, yep, because 50 is greater than 30, so CLT is met. Independent, yep, because I'm sure the population of San Diego is greater than 500. Okay, do. So now we go to our point estimate, 3.72, plus or minus 1.96, our Z-star French guy for the 95% CI, sigma divided by square root of n, and you get this confidence interval. Your conclusion will be, we are 95% confident that the mean number of times a San Diego family goes out to eat in a week is between 3.03 and 4.41 times. Do not round these, leave them as stated, okay? Then finally, our sketch, okay? Our sketch here, which is horrible because I squeezed it in. You put your mean in the middle. Your point estimate was 3.72. You show that you are going 95% around it, which is just about 2 standard deviations away from the mean, 1.96. And that gets you between 3.03 and 4.41 or 4.42. I can't remember. I have something there. Maybe I rounded weird. Okay. But that's your sketch. All right. With that in mind, now what I want you to do is the second problem. Let's see if this, oh boy. There it is. Okay. Not good. Sorry. There we go. So let's take a look at this. A bakery wants to estimate the number of cupcakes sold on Valentine's Day. They take an SRS of 20 bakeries and find that the average number of cupcakes sold was 577. Assuming that the population standard deviation for cupcakes sold on Valentine's Day is 45, notice that's giving you the standard deviation of the population. Construct a 95% CI for the true mean number of cupcakes sold on Valentine's Day. All right, I want you to pause the video and get that work done, and then come back and see. All right, hopefully you got this done. Let's pull this up for you to look at. Again, our state, sorry, it's crammed in here. We are constructing a 90, I think I did a 99, didn't I? You know what's happening is some of my old files, this was the old file I pulled up. Dang it, this should have been a 99. How about if I do this? I'm going to change this to a 99% CI right here. And then show you the work for the 99. Okay. You can take a look and compare yours. I might be deleting that part out of the video. We'll see if I can figure that out. Okay. So we want to do a 99% CI for the mean number of cupcakes sold on Valentine's Day. Notice that's what we're doing. I'm going to keep emphasizing this. Our population and our parameter are in that statement. Conditions, SRS, given. Normal, and it's only 20. So not large enough. What did I say we put there? Proceed with caution, okay? independent, we're going to assume that 200 is less than all the number of bakeries that are around. Okay, so we're just assuming that and saying okay. So now here's our point estimate, plus or minus. Sorry about that. I put the Z star for 99, which is 2.576. Hopefully then you have your sigma divided by square root of n. And I got this confidence interval. That's the do. State, plan, do, now conclude. Okay, we are 99% confident that the true number of cupcakes sold on Valentine's Day is between these two numbers. And we need to state if normal is okay, because we did not have that before. Okay. And then the CI here, I don't know why this is bad, but this is 99%. And then you have from 551.08 to 5 to should be to 60. There it is, 602.92 on the two ends, just with 90%. And the very middle is 577. Okay. Sorry for all that, but I think we've finished today's lesson. You know how to look at the table. This was a long one. Hopefully this basics of CIs is coming around for you. Okay. The next lesson will be, let me just cancel this, coming to you on section 2. All right.